Let's solve this problem. Los Angeles, let's say this is Los Angeles, and here we have San Francisco. The distance between these two cities, let's say x equal to 400 miles. And Alan travels at steady speed, 50 miles per hour. Steady means constant. Steady means constant velocity. So constant velocity means this is uniform motion. We can find time. So we can use equation x equal to vt, velocity times time for Alan. From here, time equal to distance divided by velocity. Distance is 400 miles, velocity 50. So time equal to 8 hours. 8 hours. So basically Alan will reach the San Francisco after 8 hours. We know that Alan left the Los Angeles at 8 o'clock. So it means he will reach San Francisco after 8 hours. So time will be 16 p.m. Yes, 16 p.m. At 16 p.m. or 16:0. Sorry. In the 0, he will be at San Francisco. Now we have a second person. Velocity given 60, again steady. Steady means constant velocity, but this person lives at 9 o'clock. So question is, who gets to San Francisco first? So again, we need to do the same calculation with different datas. So again, distance is same, different velocity, different time. So time equal to distance divided by velocity of the second person, which is basically distance 400 same, speed 60. So answer will be 400 divided by 60, it will be 6.7 approximately. After 6.7 hours, second person will be at San Francisco. But we know that he left at 9 o'clock. So 9 plus 6.7 hours, it will be 15.7. At 15.7 00. So it's basically second person will reach the San Francisco before the first person, because first person will reach San Francisco at 4 o'clock. 16:00. But second person will reach before the first person, because time is 15.7, which is less than 16. So at approximately 3 hours, at 3 o'clock, yes, approximately. So second person will reach the San Francisco first. Now we have a second question. How long does the first to arrive have to wait for the second? How long does the first to arrive have to wait for the second? So basically, the second person, how many minutes or seconds needs to wait for the first person, because he reached the San Francisco before the first one. So basically, let's solve it in terms of minutes. I think in terms of minutes it will be easy. So 6.7 hours, it means 6 hours and 0.7 hour equal to 42 minutes, yes, approximately 42 minutes. So basically 15 hours 42 minutes. This is exact time that the second person will reach the San Francisco. So how many minutes he needs to wait? So 16:00 minus 15:42, it's approximately 18 minutes. Second person needs to wait for 18 minutes.